Good morning, good evening, good afternoon. Today we are going to talk about the assessment of a tray bioreactor for solid-state fermentation of monascus rubber on coconut shells. Uh, give it up for Andrea.
Solid-state fermentation is a system in which microorganisms grow on a moist substrate without free water, creating internal gradients of moisture, temperature, and oxygen. These gradients directly influence germination, gas diffusion, and the organism's ability to colonize the material. SSF also involves aeration constraints because oxygen enters only by diffusion, and this can be limited in closed systems or in thicker beds, leading to microenvironments with CO2 accumulation. These challenges make small-scale SSF reactors difficult to stabilize, which is a relevant problem. Even a slight variation in moisture or aeration can prevent the target microorganism from establishing itself. For fungi, such as Monasco rubber, which require adequate oxygen and balanced moisture, these physical conditions determine whether the culture subsists or fades. Within this context, the objective of our study was to evaluate whether a tray-type reactor built with coconut substrate could maintain a physically stable microenvironment suitable for the growth of monascus rubber under solid-state fermentation conditions.
Okay. The methodology centered on the construction of a two-tray system placed inside a hermetically sealed glass vessel. To build the reactor, metallic trays were fabricated using fine wire mesh, shaped and cut into great circular supports to lift securely inside the jar. These trays were arranged at different heights using rigid supports in a vertical gradient for aeration and moisture. The coconut substrate was chopped, sliced, and cut into small pieces, conditioned, and sterilized before being placed onto each tray. The vessel lid was modified to include several openings. Some served as air inlets, equipped with filters to prevent contamination, while others allowed insertion of a thermohygrometer, proof to monitor internal temperature and humidity. After assembly, the entire system was autoclaved to ensure sterility, and inoculation was performed under aseptic conditions for both trays.
No growth of Monascus rubber was seen in either tray. The lower tray showed contamination because the moisture was too high and the air could not move well. The upper tray stayed without growth, most likely because it did not have enough moisture. We also saw water drop inside the reactor, which shows that the moisture was not even evenly distributed. This uneven moisture helped that contaminate growth and stop the target fungus from stabilization.
Next, we will continue with the discussion. In the lower trade, we observe a white fungal contaminant, which is completely different from the characteristic red or orange pigments produced by monascus rubber. This suggests that aeration inside the reactor was insufficient, even though it has a gas of outlet. Limited airflow likely causes to accumulate, preventing rubber from stabilization. In contrast, the upper trace shown no colonization at all. This aligns with conditions of low moisture or reduced water activity. A common report in solid-state fermentation systems with unit humidity distribution. Overall, the internal microenvironments, especially humidity gradients, vertical position, and resting airflow favorite contamination and inhibit the target fungus. Um, and finally, in this query code, you can find a reference used in the study. Thank you very much.